Hello, everybody. Welcome to another video of visualizations in Python on the Observer Intelligence channel. My name is hoss.belyadi, and let's go ahead and continue where we left off last time. So if you recall, we covered box plots and distribution plots in Plotly, and in this video, we're going to continue on with scatter plots. Let's do scatter plots, and let's just change this to a heading and do a shift enter, and then let's just go ahead and do px.scatter. Let's go ahead and under data frame, let's go ahead and import the df data frame that we have. For x, let's have the x variable as a prop and loading, and also let's have the y variable as let's call it EUR, for example, in this case. And let's color this by let's do category, see what it looks like. Let's run this. Here we go. So you can see here prop and loading versus EUR, and you can see here the red is vintage wells and the blue are the new design wells. You can see the new design wells had higher prop and loading in this case, for example. Okay, so this is just a one way of creating these scatter plots within Plotly Express. So with that, let's go ahead and do a line plot now. Line plot. And let's change this to a heading again and do a shift enter. And let's go ahead and import the natural gas pricing, what we imported in one of the previous videos again. And let's just say, let's call it df2. I'm just making up a name. Let's call it pd.read. And let's go ahead and import that Excel file again. And by the way, just a quick remark on that. You can do pd.read and hit tab here, and you can really import any kind of format that you have. For simplicity, I'm just importing a bunch of Excels and CSVs, but you can really import anything into Python and work with those files, just FYI. So now let's go ahead and import the historical natural gas pricing. And if you recall, the df2 had two columns, date and Henry Hub natural gas spot prices. So what I'd like to do now is go ahead and get the year for those dates. And also I'd like to add the first and second period based on a filtering that I'm going to add. So I'm going to say df2, I'm going to say year is equal to PD. Let's just go ahead and do date time index, and let's go ahead and do df2, and I'd like to get the date time index for the date column, and I'd like the year in that column. So if you run this, it's going to give you, if you do df2, you can see it added the year associated with these dates. You can do month, or honestly, you can do anything that you're interested in. Just FYI, if I change this, for example, to month, and change this to month, if I run this, now it's going to give me, the month. But for this example, we're just interested in the year for now. So let's just go back and change this to year. And let's change this to year. And I'm going to rerun the code again from top down. So give it a second. Here we go. And also, I'd also like to add a couple other things. I'd also like to add, let's go down here, for example. I'd like to say df2.lock, and lock stands for location. And let's go ahead and type in df2, and then in the created column year, I want to say if that is greater than or equal to 1997, for example. And I'm going to create parentheses here and say DF2 year is less than or equal to 2010, for example. Let's go ahead and put comma. I'd like to create a column called category, okay? And also I'd like to, if these two conditions are met, I'd like to call that row of data, for example, first period, okay? I think we've done this in one of the previous videos, but I'm gonna copy and paste the same thing, and I want to say from 1997, 2010, I want to say from 2011, for example, to 2022 in this case. And let's call that a second period. There we go. If you do DF2, you can see here it created a category column. Now it has first and second periods now. Okay, so now let's go ahead and let's do a line plot. So let's do px.line just like that. And let's pass in the data frame. The data frame is going to be df2, not df, just going to be df2. That's the second data frame that we imported. And then x is going to be date, and y is going to be the this column right here, the Henry Hub. It's pretty long, so I just copy and pasted it right here. And basically, what I want to color it by, I want to color it by category, which is the new column that we just created. When you run this, here we go. So you can see here the natural gas pricing, and you can hover over it. You can see natural gas pricing at each point. You can see it was like in 1997, on October of 1997, it was $2.84 per MMBTU. You can hover over it. And as I said in the previous video, the beauty of Plotly is that it is interactive. So you can interact with this plot. You can zoom in if you're interested in some of these. For example, what happened here, you can zoom in and see much better. You can always go back and hit auto scale, revert back to what it was. Okay, so this is called a line plot, which you saw is just literally one line of code, pretty easy to make. And then let's also create some bubble charts. Bubble chart, and let's just change that to a heading, and let's do OK and do Shift Enter. So for bubble chart, let's just call it px dot. Actually, we can do px dot scatter, and what I can pass in data frame is equal to df, the first table that we created together. So propant x is going to be propant loading, and y is going to be EUR, for example, in this case. And let's color this by EUR, and let's do size. There's another argument that I can pass in called size max, and let's pass in, for example, 15. If I run this, here you go. You can see it created this chart with and you have the EUR as the color on the side, and you can like clearly see which designs yielded the highest EURs. In this case, the most of these higher propant loading yielded higher EURs. Again, this is just a simple scatter plot, and what you can do is play around with this to, for example, 20, and see what it looks like with that. So here's one way of creating these bubble charts, and to kind of see what is going on. And also another plot that I wanted to cover is, let's call it a heat map. This is not the heat map that we've covered with the Pearson correlation. This is just a heat map of kind of showing a heat map of that scattered X and Y plot. So let's do heat map, and let's just do heading and do OK and do Shift enter. Let's go ahead and do px dot, it's called density heat map, and let's pass in a data frame of df, and then x is going to be prop and loading again, and let's do y is equal to EUR, and let's go ahead and do color continuous scale. Let's go ahead and do give it a different coloring scheme, like the scheme called Verdis. Okay, you'll see in a minute what it looks like. And if I run this, there we go. You can see here heat map of EUR versus prop and loading, and basically it's just a heat map. This is not the same as Pearson correlation coefficient stuff that we discussed in Seaborn. This is a bit different, but you can simply use the density heat map syntax here within the Plotly Express. And what I like to do is you can always add number of bins and bins y, and let's just find this 20. And here we go. You can see higher resolution here, and see what's going on. And these are just a count of how many, like for example, wows you've had between this EUR range and also between that prop and loading range. So you can hover over this and kind of get a picture of what's going on in your data. So that's another one. And you can also do a similar density heat map. Let's just, for example, copy and paste this. And what I'd like to add is, let's do copy and paste this. And what I'd like to add, in addition to all we had, I'll also like to, if you, for example, get rid of this, this Verdis color continuous scale. Let's just get rid of that. Let's put comma here. Let's add in a couple more arguments called marginal x and marginal y. And let's just ask for histogram, histogram for marginal x. Let's just copy and paste this. Here we go, margin. Let's actually go push this down here so we can see it better. Marginal y, and do histogram. There we go. So you can see here, it added the distribution plot for example, the prop and loadings distribution plot is at the top, and then the EUR distribution plot is on the side right here. So you can see this all combined into one, which is pretty nice. Nice to see. These are great plots for visualization purposes. So feel free to play with that. So now that we've covered some of the heat map, the density heat maps, let's move on to violin plot. Violin plot. And let's just change this to heading as we have done in the past. Do Shift Enter. Let's do px.violin. And let's again pass in data frame is equal to df. You can see how easy it is to code these. I mean, Plotly has made it super easy to code these. One line of code can get you create these really nice plots for you. So category, let's run this. Here we go. So I have X as prop and loading, and I'm basically dividing it by category of vintage versus new design. You can hover over this and pretty much see what's going on. Pretty good. You can honestly sometimes do these visualizations and just take these Jupyter like notebook files in a presentation setting and just show them within the Jupyter notebook, as opposed to taking those in a PowerPoint or something like that. Saves everybody a lot of time. You can always deploy these on the cloud through different cloud providers. You got Amazon, you got Microsoft, you got Heroku, you got all kinds of cloud providers you can use to deploy these dashboards, where you can create dashboards out of these and deploy them on the cloud. That requires combining Plotly and Dash, which is beyond the scope of what we're covering today. And also let's do one more thing. Let's do a cum probability plot as well. Let's do cum ability plot, and let's just do a heading, do OK and do Shift Enter. Let's go ahead and do px dot EC df. Okay, that's the syntax used for creating cube probability plot. Let's pass in df, the main data frame that we've been using. And let's pass in again prop and loading. I'm just trying to stay consistent here, just for the sake of visualization and illustration here. Prop and loading, let's do color, and let's pass in, for example, category. And if you run this, let's see what it says. Value of X is not the same. Okay, propent. I have an extra P in here. There we go, prop and loading. So here we go. So you can see here the vintage versus new design. You can see your Q and probability plot. As I said last time, you guys can see your P10, P50, and P90. You can always hover over it. You can see probability here, prop and loading, or this one. Do comparison plots pretty quickly. So pretty powerful stuff right here. This, we're going to stop right here. Hope this was helpful. If you like it, please like, share, and subscribe to the channel. More videos to come here in the next few days. Thanks so much, and we'll see you guys next.